Okay, welcome to this question from the 2019 AEA paper, about logarithms. In part A, we have to use that substitution and show that this statement here is true. Okay, so I'm going to make a start by working on what the fundamental definition is of u equals log to base 4 of r. Okay, so we start with this. Okay, so part A, we have that u equals log to base 4 of r. That's given. Implies that 4 to the power of u equals r. Okay, by definition. And I'm going to now write the 4 as a power of 2. So I can also say that that is equal to 2 squared to the power of u, which of course is the same as 2 to the power of 2u. Okay, so that's my starting point. Now, I'm also going to use the change of base rule and change this into a logarithm of base 2. Okay, so I can actually say that u is also equal to log to base 2 of r. Okay, so I've changed the base from 4 to 2. But in order to correct that, I have to divide by log to base 2 of the old base. Okay, so log to base 2 of 4. And that's a standard rule that you can use, and it's fairly easy to prove. So we can use that rule there. Just going to move that line down slightly. All right. So that follows then from there that if I multiply both sides by log to base 2 of 4, okay, I can say that u times the log to base 2 of 4, okay, or log to base 2 of 4, okay, times by u is going to give me log to base 2 of r. Okay, and I can also now rewrite that log to base 2 of 4 as its actual value, because the log to base 2 of 4 is of course 2. Okay, because 2 squared is 4. So I'm going to replace that with 2. So it implies that 2u equals log to base 2 of r. Okay, and it's now starting to look a bit like what we're looking for. If I divide both sides by 2, I get u equals, I'm going to use this space over here. So just dividing by 2, I therefore have that u equals a half log to base 2 of r. Okay, and I know, of course, that u is in fact log to base 4 of r, so that's my result that I'm looking for, isn't it? So I can now just replace that u with log to base 4 of r. Okay, equals a half log to base 2 of r. Okay, so that is the result I had to prove, and step by step it's been done there. Okay, good. So that is part A for 2 marks. And that's just really using some of the fundamental rules of logarithms, the basic definition, the fact that it's the inverse of a power, the fact that you can change the logarithm base, and so on. Okay, now in part B, we're going to be using some of what we've done in part A, almost certainly. So we have an equation that's given with log to base 4 on one side and log to base 2 on the other. So that's a big clue that we're going to be using something we've just been looking at here. All right, and of course the very first thing I'm going to do is take that result that we've just proved and replace the log to base 4 with a half log to base 2. All right, so my first point of reference is that, and I'm going to write a half log to base 2 of 5x squared minus 11 is equal to log to base 2 of the other part, 3x minus 5. Okay, so I have immediately used the result that I have just proved. Now, I can of course raise both sides. Well, I can take the logs out, but before I do that, I need to put the half over here to become the power. So strictly speaking, I'm just going to do this. I'll do this in 2 steps because really that's what you would need to do. So I'm going to write that log to base 2 of 5x squared minus 11 to the power of a half. Okay, now remember that power belongs just to the bracket, not to the log as well. Okay, is equal to log to base 2 of 3x minus 5. Now clearly I've now got 2 expressions, both of log to base 2. I can just take the logs out and say that 5x squared minus 11 to the half equals, okay, the right hand side without the log. So 5x squared minus 11 to the half is equal to 3x minus 5. Okay, well, I just need to square both sides, and that will get rid of this half here. So I can say that 5x squared minus 11 is equal to 3x minus 5 all squared. Now I'm putting in every step here, okay, and if time allows in the exam, you would be encouraged to do every step. There's possibility to take some of these steps out in the middle, but for the moment we'll stick to the full working. All right, so the next thing is just to multiply out that bracket on the right and then sort it all out into hopefully a quadratic that will solve fairly readily. Well, that's going to be 9x squared. Okay, we've got minus 30x plus 25. Okay, just multiplying out that bracket. And if we put everything to one side, we're going to have 4x squared. Okay, minus 30x. And then we're going to have plus 36 equals 0, and hopefully you will see that that can be reduced down by a factor of 2 to give me 2x squared. Okay, minus 15x plus 18 equals 0. Okay, now if it factorizes, there's going to be a 2x and an x. And a little bit of inspection of that will show that it does work. Okay, so it's going to begin like that. And the 18 is going to become from a minus 6 and a minus 3. Okay, and that does indeed work. Okay, so we know that the possible values of x are therefore 2/3 3 over 2, I should say, 3 over 2, or x equals 6. Okay, now I need to look carefully now at the two solutions I've just arrived at, because it may be that they can't be used in the original expressions. Okay, because the log value can't be a negative number or 0. So I just need to establish if that's the case. Okay, now if I put here in this bracket 3 lots of 3 over 2, that's 1.5, times 3 is 4.5. 4.5 minus 5 makes a negative number, negative 1/2. Therefore, it cannot be 3 over 2. All right. If you put 6 into either of these, you end up with a positive number, which is okay. So the only valid solution is 6, but we should exclude the 3 over 2 and explain why. So my solution is going to be that x equals 6, okay? X does not equal 3 over 2, since, and I would just say something like this, 3 times 3 over 2, okay, minus 5 equals minus 1/2, okay, which is less than 0. Therefore, log to base 2, or log of any base, of 3x minus 5 is undefined. Okay, it's not a number that we can evaluate. All right, so we've had to show that we've eliminated one of the solutions and the reason for it, leaving us with the only valid solution, which is that x equals 6. Okay, and usually I do something along the lines of this as well, just to show that I've considered both options. Okay, and that's the end of that question.